Tonight we're going to be talking about our hydrates. And when you think of the word hydrate, I'm hoping you think of presence of water. And that's exactly what a hydrate is that you have this molecule, okay? So let's say we have this molecule. I'm going to say CuSO4, okay? And what happens is that it's a hydrate when these little water molecules are loosely attached to that big molecule. All right. And all you have to do to get rid of them is heat them up, and you are left with, once again, the same, just CuSO4. Okay. And then these little water molecules, oops, wrong color. These little water molecules are around. Okay. When I'm looking at this, this is known as the hydrate. Okay. And this is the anhydrate. So without water, okay? So we've got the hydrate, which has water loosely attached, and a lot of molecules actually naturally have water loosely attached to it. And then we have the anhydrate, where it's like basically dehydrated. Now, if I wanted to go hydrate again, all I'd have to do is add a little bit of H2O, okay? And then these molecules would instantly attach themselves naturally, all right? So a hydrate is a chemical compound that contains water, okay, that can be expelled by heating. So typically you just put it under a Bunsen burner and it'll heat off, okay? And you don't decompose the compound. So it's not like when we're heating it up, we're breaking this copper 2 sulfate into copper and sulfur and oxygen. All we're doing, as I demonstrated before, is taking off those water molecules. As I showed in the previous slide, an anhydrate is without those water molecules attached, and a hydrate has the water molecule attached. Now, if you look at this formula, this is how you write a hydrate formula, which we'll go into in a little bit, but you write the ionic compound, or the formula of the main substance of the anhydrate, and then you put a dot that shows that it's loosely attached, and then you write how many water molecules are loosely attached to one of these guys, okay? So that's how you write a hydrate, is you do the compound with a dot, and then how many waters are loosely attached to it. All right, so how do you name it? First, the ionic compound is named first using the rules for ionic compounds. So that's just traditionally how we would name it. So this guy, I'm going to say, would be copper 2 sulfate. Nothing different so far. Greek prefixes, these are the same ones that are used for covalent compounds, so mono, di, tri, are attached to the word hydrate to indicate the number of water molecules per formula unit for the compound. So what that means is this is 5, so knowing your covalent prefixes, this would be penta, and then you just add the word hydrate. That's it to naming it. All right, so the next one, CaCl2 dot 2H2O. So this would be calcium chloride. Step 1, and then you just say what the prefix, which would be dihydrate. Done. Okay, magnesium sulfate heptahydrate. So we're going to name this magnesium, has an Mg plus 2. Sulfate is SO4 minus 2, so we end up with MgSO4. And then when you're given the chemical formula, we're trying to write it out, you put it a dot, okay? Hepta is 7, and then hydrate means water. So you got MgSO4 dot 7H2O. All right, so we're just going to do one practice problem, and these are the steps that you're absolutely going to need to know how to do. We're going to be doing a lab, hopefully, and it'll be on the test and stuff like that, so make sure you have these steps memorized. It is a very similar process to empirical and molecular formula. So reading this problem, it says that a 15.6 gram sample of a hydrate of MgSO4 was heated without decomposing, and the water was driven off. So originally, this 15.67 has that water molecule attached to it. The mass was reduced to 7.58. What is the formula and the name of that hydrate? So what this is saying is that the water was driven off, so that 7.58 is of whatever the ionic substance was. So when I need to find the mass of the water and of the anhydrate, this 7.58 is the anhydrate. So that would be 7.58 grams, and the anhydrate was MgCO3. Okay, then we need to find the mass of the water. Well, originally it was 15.67, and that had the magnesium carbonate and the water, and then it went down to just the magnesium carbonate. So the difference would be the water that was driven off. So 15.67 minus 7.58, I get 8.09 grams, and that would be of my water. Convert the mass of the anhydrate to moles. So all I'm going to do is convert this to moles. I have to figure out the molar mass. So this would be 24.1 plus 12 plus 16 times 3. So we get a total of 84.1 grams of MgCO3 for every 1 mole of MgCO3. Multiply that out and you get 0.09013 moles of MgCO3. Okay, now convert the mass of water into moles. So 8.09 grams. Water is 2 times 1 plus 16. So we get a total of 18 grams of H2O for every 1 mole of H2O. That equals 0.449 moles of H2O. Now we're going to find the mole of water to mole of anhydrate ratio. So what you're going to do is divide by the lowest number. So in this case, I'm going to divide 0.09013 by 0.09103. It should always be the anhydrate, by the way, the MgCO3 or that ionic compound. So for this one, we get a 1. And when we divide this by 0.09013, you get 4.99, which rounded is 5. So create a formula from this ratio. So we have MgCO3, you always write the anhydrate first, dot 5H2O, okay, because that was that 5. Sorry, I'm going to get rid of that so you don't get confused. So that would be your formula. And what is the name of the hydrate? Magnesium carbonate, pentahydrate. And there you go. Hopefully you have a basic understanding of how to create hydrate formulas and name them.